Hey friends, it's me again. I hope you're enjoying your last day of spring break. What I'm going to do is I'm going to recap what we learned on Friday and also what we're going to be going over again tomorrow in class. Please make sure that you have a piece of paper out and your pencil out so you can copy down all these notes. Remember, to get credit for this, you need to turn in notes that all the ones I've done and then also the practice problems at the end. First thing we are going to do is we're figuring out what's going on. So the question says, graph the quadratic and label the key features: axis of symmetry, vertex, y-intercept. Let's start by just reviewing what we know about quadratics. So we know the general shape is a parabola, which is going to look like a U shape. You do not need to copy this on your notes, I just want to show you. Then, once we have our parabola, we know some things about it. We know that this is called the axis of symmetry. Actually, do copy this down just so you know what it is. Label that AOS. Axis of, wow, that's horrible. Axis of symmetry. It's the thing that divides our parabola exactly in half. So it's the same on both sides. The U, if you fold it over, would be the same around this axis of symmetry. And it's always going to be an equation because it's a line. So x equals, in this case, 1, 2, 3. X equals 3. Then we also know one more crucial point, and that is our vertex. Hopefully you remember the relationship between the vertex and the axis of symmetry in that they have the same x value. The axis of symmetry goes through the vertex, so I'm going to label that V for vertex. Now we need to actually find these things for this equation. So make sure you have some blank paper. We're going to start by writing what A, B, and C are. So pause the video, write what A, B, and C are. If you remember how to find the vertex, start doing that now. So check your work against mine. We always know quadratics are in the form ax squared plus bx plus c. That's standard form. A is the coefficient of x squared, so in this case it is 2. B is the coefficient of x, so it is 4. And c is the constant. It's by itself. It is 1. Hopefully you got those correct. Now to find the vertex, we are going to use a formula that is on your star reference sheet, so you don't have to memorize it. It is x equals the opposite of b all divided by 2a. So when we substitute in, I'm going to do this in color so hopefully you can see it. This b value is going to be 4, and my a value is going to be 2. So finish solving this by yourself. Check your work with mine. Once I substitute in for a and b, I simplified that fraction and got an x value of -1. We know our vertex is not done yet because a vertex is a point. So it needs to be in the form of a coordinate x, y. Now that we have our x value, our input, we can actually use this to find our output. Think back to the idea of functions. We use an input, we substitute it in, and we find an output. In this case, we are going to use -1 as our x value to find the output when x is -1. Please pause the video, substitute this back into the original equation to find y. Once substituted in, you should have had this. All we did was substitute that x equals -1 in for everywhere where I saw x in my original function. What I'd like you to do now, pause the video again, simplify, find your y value, write your vertex as a coordinate x, y. You should have had h of -1 equals -1. So when x is -1, y is -1. Hopefully you realize that I made a mistake here. I have not yet written the vertex as a coordinate, so I'm not done. Write that as a coordinate, and then we're going to move on. Your vertex should have been -1, -1. So all I did here was rewrite my problem so you can see the vertex is -1, -1. I then graphed it at x equals -1, y equals -1, and labeled it with a v, as you're going to do on your notes. Then to find the axis of symmetry, it's really easy. We know the axis of symmetry goes through the vertex. Whoops, missed that one. It goes through the vertex, so it must go through here. Wow, there you go. Look at that line. I put arrows on the ends because it goes on forever. That equation, it only goes through the x-axis at -1, so I know it is x equals -1. Hopefully you guys see that connection there, that, hey, the x value of the vertex is the same as the axis of symmetry, since it goes through it. Finally, we're left with our y-intercept, and this is actually the easiest one. The y-intercept is just c. So think back, we found c, it was +1, so our y-intercept is going to be the coordinate 0, 1. I know that looks like a 6, but I promise you that is, oh wow, now it looks like an 8. I'm not helping it. Okay. 0, 1, you get it. We're going to graph this at 0 on the x-axis, 1 on the y, so there's our y-intercept. We now have our axis of symmetry and our y-intercept and our vertex. This is my favorite part. What we're going to do now is use this property of symmetry, which means it's the same on both sides, to find our bonus point. We know that this guy, our y-intercept, is 1 away from the axis of symmetry to the right. If it's the same on both sides, we can start at our axis of symmetry and go how many to the left? Well, 1. You're totally right. So our bonus point here is going to be the coordinate right there, the exact same distance on the other side of the axis of symmetry. What we're going to do now is finally finish this by making a nice smooth parabola. I apologize in advance because mine probably won't be smooth. Start at the vertex, go through your y-intercept. Not too bad. Again, start at the vertex, go through your bonus point. Make sure you add arrows so you remember it goes on forever in both directions, because that's going to help us with domain and range. Only thing I want to do is, on your notes, you're going to have to do this as well. So please label this AOS for axis of symmetry. I'm about to put up another problem. I'd like you guys to solve it, and then I will show the answers. Here is your next problem. Please find the vertex, the axis of symmetry, and the y-intercept and the bonus point, and graph it. Pause the video because I'm going to show the answers right after this. For this problem, you should have had your vertex at 4, -9, your axis of symmetry is x equals 4, and your y-intercept of 0, 7. One thing I do want to point out is that your graph should look better than mine. Make sure you are using straight, precise lines so you don't get confused when you're graphing. What I want to note is that remember the relationship between the vertex and the axis of symmetry. Say it to yourself before I say it. The relationship between the vertex and the axis of symmetry is that the axis of symmetry goes through the vertex, so they have the same x value. Also, remind yourself, how do we find the y-intercept? The y-intercept is our c value. Finally, tell yourself how to find the x value of the vertex. The x value of the vertex is found using the equation opposite of b divided by 2a. Again, how do we find the y value of the vertex? We take the x value found or the input, we plug it back into the original equation. I'm going to give you one more problem, and then you guys will be good to go. Here's your final problem. Please pause the video, do all the work, and then we'll check it. So this should be the final one. Hopefully your graph looks less tragic than mine. Make sure you understand how to do this, specifically understanding how to use the formula opposite b over 2a to find the x value of vertex, and plugging that x value into your original equation to find the y value. Hope you guys had a good spring break. Please turn these notes into me with all your work to make sure you get full credit. And I'll see you tomorrow.